Good morning, ladies and gentlemen, and happy Monday. Today is April 20th, 2020. Welcome to another episode of Mr. Vasquez's Online Math Lessons. Lesson 5, Triangles in Circles. That's right, our last lesson was called Quadrilaterals in Circles, and I made you think for a second we weren't putting triangles in them. Well, guess again, we're putting triangles inside of circles. Let's get into it. 5.1. Here we have to construct the perpendicular bisector of segment AB. So this lesson is actually designed to be very hands-on, and normally in class, I would give you guys your compasses, and we would be doing all of these constructions from Unit 1 when we first learned this. But here, I'm just going to talk through what these constructions would look like and what they really mean for the circumscribed circle. So let's do some virtual constructions. Here's triangle ABC. We're going to do the perpendicular bisector of segment AB. So we're going to start off by drawing a circle centered at A with radius AB. Then we draw another circle centered at B with radius AB. Then we connect their intersection points. And this line is the perpendicular bisector of segment AB. Now imagine any point on that perpendicular bisector D. Any point on this perpendicular bisector has to be the same distance away from both A and B. This was one of the very first theorems that we learned. This perpendicular bisector is the set of points that are all the same distance away from both A and B. So that was one perpendicular bisector. But what if we make another perpendicular bisector of segment BC? First, draw a circle with radius BC centered at B, then do a circle of the same size centered at C. When we connect their intersection points, we get the perpendicular bisector of BC. Now I want to take a look at where those perpendicular bisectors intersect, and let's call that point P. And we're going to clear away those circles so we can really focus in on that intersection point. So now I'm going to draw a line segment from point P to all the vertices of the triangle. What has to be true about those line segments? Well, we know that PA and PB have to be the same because it's on the perpendicular bisector of AB. And all the points on the perpendicular bisector are the same distance away from both points A and B. But P is also on the perpendicular bisector of BC. So therefore, PB must be the same length as PC. So that turns out all three of those line segments must be the same. So what do you think would happen if we made the perpendicular bisector of segment AC? Well, we already know that P is the same distance away from both A and C. Therefore, P must be on the perpendicular bisector of AC. Let's take a look. This is what our construction would look like. And if we clear away those circles, we can clearly see that perpendicular bisector goes straight through point P. Next, let's draw a circle centered at point P with radius PA. This is what the circle would look like. Let's clear away those perpendicular bisectors as well so we can clearly see what just happened. This circle hits all three vertices of the triangle. Why? Well, I used radius PA to make my circle, but PB and PC, since they're all the same length, they're also all radii of this circle. So this is how we construct circumscribed circles around triangles. That point P is a very special point. We call that the circumcenter of the triangle. It is the intersection point of the perpendicular bisectors of all three sides. So when we make a circle centered at P with radius PA, we know that it's equidistant from all three vertices of the triangle. So this is just one example of us constructing the circumcenter of the triangle. In the next activity, we want to be able to find the circumcenter for any triangle. And this is something we can do no matter what the triangle looks like. We can always find the circumcenter, which means no matter what the triangle looks like, we can always draw a circle that goes through all 3 points of the triangle. Now, where the circumcenter is going to be different depending on what the shape of the triangle is. Let's take a look at these 3 shapes and figure out where the circumcenter is. On the right triangle, we can see that the circumcenter is on the hypotenuse of the right triangle. This makes the hypotenuse the actual diameter of the circle. So why is that? Maybe it has something to do with that 90-degree inscribed angle. Something to think about. For the obtuse triangle, we see that the circumcenter is outside of the circle. This can happen. Even though we call it the circumcenter, oftentimes we do think about with the acute triangle and how the circumcenter is inside the triangle. But the circumcenter, remember, is the center of the circle that goes through all 3 vertices of the triangle. So it doesn't even have to be in the triangle itself. When the triangle is obtuse, the circumcenter is outside of the triangle. And for acute triangles, we see the circumcenter will fall inside the triangle. So I wish we could have done this lesson with our compasses in class, but I'm really hoping that you were still able to take away these 3 main points. Number 1, that all triangles have circumscribed circles. No matter what the triangle looks like, we can draw a circle around it that goes through all 3 vertices. And that circle has a center at the intersection of all the perpendicular bisectors of every single side. This is because the perpendicular bisector have the points that are equidistant from the endpoints, and that's what we needed to circumscribe the circle. And that point is called the circumcenter of the triangle. And it's the center of the circle that circumscribes the triangle. So that's all we have for today. If you like this video, make sure to like and subscribe. And until next time,